Welcome back, everyone. So, without further ado, I present you my new furnace. So, I know this is a lame video to make, but I'm doing a lot of homeowner videos these days because I just bought this fixer-upper house and it needed, well, damn near everything. So, this was probably the biggest project, the second most expensive thing I've had to do to this house since I bought it. The first thing I had to do was a new roof. That set me back nearly 13 grand. Again, the next thing down on the list for major repairs, the heating system. This house was built in 1954, and it still had, as of the spring of 2019, its original furnace. So I want to talk a little bit about why. So this is an oil furnace. Here's the oil tank. Before we dive into this whole thing, let's talk about why I chose oil over natural gas or heat pumps or solar. I talked about this in an earlier video, but I need to reiterate it here because I just have to, because YouTube. Everyone's got an opinion. So, natural gas is an option that I would love. I wish I had natural gas, but there is no infrastructure in this part of the city, so I cannot tap into natural gas. That sucks. But I would gladly take this particular neighborhood over any other neighborhood that is served by natural gas because it's pretty much in the more concentrated areas of the city. So that's why we don't have natural gas here. New Hampshire is a unique place. New England in general is a very unique place in that we don't have the infrastructure that some of you Westerners, Southerners are used to. We just don't have it. This is an older part of the United States. It was built up a lot earlier than some of those other areas. And the terrain is kind of rough, so that's why we don't have it. The second thing is propane is an option. Propane it's basically a truck filled with volatile gas, and they deliver it to your home by pumping it into an external tank. It costs almost as much as oil, if not maybe a little bit less. But I've already got a tank here, and if I were to convert to propane, it would have cost me a few $1,000s more, I think. So that was out. Oil is basically what we have here. It's New Hampshire loves its oil, and the current oil that we use, that we burn in our homes, is it's a blend of biofuels and fossil fuels. It's not straight fossil fuels. And it doesn't burn, I think it's low sulfur, so it doesn't burn as dirtily. It's not as harmful as it used to be, but I'm not going to put lipstick on a pig. It's dirty and it smells bad and oil sucks, but it's what I got. The fourth option, heat pumps. So heat pumps, there are some models that can be used in colder climates like New England, but they're very expensive. They're not as reliable as an old-fashioned fuel-burning unit, but they cost a whole lot more than what this would have cost. Most people in New England who have heat pumps use them as a supplement heat. Now the other thing is I did not opt for an air conditioner. So this house does not have central AC. It could have been done at the installation time. I could have had an A coil added to this unit and I would have central air. But and that's going to play into something I want to bring up in a little bit. So no central air. I didn't want to pay for it. I've spent enough money as it is, and if I had central AC, I would never use it. Because another thing that New Hampshire is known for is we're like the third or fourth highest as it pertains to the cost of electricity. We are one of the highest in the nation. I spend a lot of money on electricity as it is. I don't want to raise that any higher. I can live without AC. My girlfriend can't, but that's her problem. So that's kind of where I'm at. So this is why I chose oil. This is why I don't have air conditioning. And let's roll on. So I got 3 quotes. The first one was from the oil company, the delivery company. They wanted to sell me the most expensive furnace that money can buy. They wanted to sell me a Thermopride, which is a fantastic product. But installed, they wanted to charge $8,000. That's a lot of freaking money. So I asked them to give me a quote for a less expensive unit. And they begrudgingly gave me a quote for a very similar furnace to this one. It was a Rheem with a single-speed permanent split capacitor blower motor. And the price that they gave me was around $6,000, so still a little on the high side. The second quote I received was from the company that serviced the original furnace. They were the last company to service it. And they told me that they could sell me a Rheem. Now, they all seem to recommend Rheem products. They're pretty popular, it seems, at least as far as oil furnaces go. And they wanted to sell me basically the same furnace that the oil guys did. And their price was somewhere around $5,000, up or down. I forget whether it was above or below $5,000. So I then got a third quote from a company that my girlfriend actually, she knows the owner, and so we had him come over and get a price. And I told him I'm not looking for any special discounts or anything like that. I just want a decent unit installed right. So he told me that he could do this particular unit here, but with a PSC permanent split capacitor blower motor for $49.90 installed. So I then thought about it. I'm like, why don't I just I'll get that furnace, but we'll do an ECM blower. They seem to be pretty well regarded. The ECM blower, what that does is it intelligently delivers the air based on furnace load. So on a low demand heating cycle, it'll run the blower at a lower speed, and it gradually ramps up as needed. So the other thing that an ECM blower does is it doesn't come on full speed at once, so you don't get the dimming light effect that happens in some older units. The original furnace, the lights would dim momentarily as the blower kicked in. The ECM blower, it ramps up slowly and it ramps down slowly. So you get a nice, there's no surge of energy consumption all at once. So it's kind of nice. So anyway, that was the only upgrade. I was originally going to buy this unit with a Riello or a Carlin burner, but the installer talked me into a Beckett because, number one, they're less expensive, but number two, they're much easier to service. Parts are readily available, and they're like the Chevrolet of old. I'm talking like in the old days here, back when the big three were the big three. But anyway, let's call it the Toyota Camry of oil burners. Make it more relevant. It's a very simple burner, very reliable, very easy to service, and that's important, especially on something that you kind of need to use on a daily basis in the winter, and you don't want any surprises or expensive repairs that are unexpected. So on 6/29/19, the gentleman who I hired to install this, he came over with his crew, and they took out the furnace that I now refer to as Asbestos Annie. She's a 65-year-old girl, and it was time for her retirement. So that furnace was much bigger physically. It was, number one, that original one sat directly on the concrete floor, and it came up to about here, height-wise. As for length, it was about 1.5 feet longer and about 5-6 inches wider than this unit is. It was a big furnace. Built with old technology, but built well. Definitely not very efficient. That thing had an efficiency rating last checked at around 78%, and that was before the heat exchanger was completely clogged with filth. So I imagine that thing probably ran at 60, maybe 65% at the most. But she's gone, and we don't talk poorly of the dearly departed. Let us bow our heads in silence. for the new one, again, we went with a ream. Now, I've heard great things about ream. I've done my research. I've really decided that that's the way to go. If I'm going to stick with oil, ream makes a pretty decent unit. They're not the most expensive, they're not the cheapest, but they're kind of like the Goldilocks of furnaces. The best one you can buy, of course, is a Thermopride, and the oil company was right on that. They make a fantastic product, and I may have gotten a longer life out of it, but I figure a unit like this, I should get around 15 years, maybe 20, maybe more, who knows. We'll see what happens. Efficiency rating on a unit like this, by the way, is around 86%. Not really many industry professionals would recommend a high efficiency oil burner. The reason being, they have a very short lifespan. They tend to corrode out very quickly. Even the stainless steel heat exchangers, the heat exchanger may be okay, but there's a lot of problems with them. They don't last, and they're just not that reliable. High efficiency gas furnaces, they're great for like 10 years, but beyond that, from what I've been hearing, from what I've been reading, they tend to fail very, very early in their lives. One of the great things about a standard efficiency oil burner is that they do last a long time. They're pretty well made. The heat exchangers are very thick steel. I think this one's it's 10 gauge primary, and or is it? I think it's 10 gauge on the primary and 14 gauge on the secondary, or it's 12 and 14. I forget what the combination is going to be, but it's a pretty heavy-duty heat exchanger. Should last a good long time. I'll take the vestibule cover off and see what it looks like in there, and then we'll take a look at the blower housing. Now, this unit is currently running in air circulation mode. That was something that I specifically asked the installer to enable, because it's good for moving air through the house. Remember, I don't have air conditioning, so this helps keep the air from getting stale. So on this unit here, we have two front heat exchanger cleanouts, and it is a front flue model. So that was just arbitrarily chosen by the installer, and he just made it work. The original one was a rear flue. We've got a Beckett AFG burner. I got it all dirty from my floor cleaning stuff. I'll clean that up later. But again, it's built by the Boyertown Furnace Company of Boyertown, PA. It's a model ROLA 070EO4F. So it's a very simple, pretty. I mean, it's not built like the old Mayflower was. That was the make of my original unit, but it's built well enough. I think I should get a pretty good life out of it. I didn't get fancy with any add-ons like a Tiger loop or anything like that. I didn't think I needed it, and nor was it even offered to me. Some installers will try to sell you the world. They're going to try to sell you the dehumidifier, the humidifier, the AC. This guy was pretty simple. He's like, this is what you want, this is what I can sell you. If you like it, sign here. So, anyway, we'll take a look at the back here. Now, there are some things that I'm not too crazy about in terms of how it was set up. Some of the wiring in here is a little messy, and so I cleaned it up as best I could, and you'll see what I mean in a minute. But it was kind of a mess, and I wasn't crazy about that. But again, we'll make it work. Now, one thing I want to show you guys in this little demonstration is why you should never ever open your blower cover while the blower is running in a basement or in a small enclosed area. Because what happens is you create a negative pressure situation which can draw exhaust air through the draft control plate and start drawing in carbon monoxide into your home. So let me just quickly demonstrate. I've unlatched that door right there. If I open this door here on the bottom of the furnace while the blower's on, and it's not at full speed right now, what's going to happen is that door, this demonstration worked earlier, but it's not working now, but that door is going to pop open. Here, let's loosen it a little bit. Yeah, it's not. Well, anyway, you get the idea. It did it earlier. So it's still running in recirculate mode, and let's take a look at a couple of things. So this is the ECM blower, and this is the whole furnace control board. And this unit is what controls, it drives the blower, it tells the burner what to do, it can control an external air conditioner as well. So it does a little bit of it does everything all in one. And kind of like what the stack switch did on the old unit. Our thermostat is wired directly into it right there, and there you go. Now there was a problem with this unit as it was installed. What was happening was, and they followed the instructions on how to configure and wire it all up. And what was happening was, after a heat call or after the fan on call is ended, it would start to click incessantly. You'd have the blower relay would click on and off, and it was going nuts, because what it was trying to do was run a dehumidification cycle. Because in the instructions, it has you jump the R wire, the red wire, to the dehumidifier terminal, or dehumidification call terminal. So it was really confusing, because what was happening was it doesn't have an external condenser installed. In order for dehumidification to work, you need a condenser, and the fan has to run at low speed. So it was waiting for the condenser to kick in to kick the fan on. Clearly, there was no condenser. What we later found out, and I figured this out because I pored over the manual, I checked a couple of different versions of the manual, and couldn't find any direct reference to how to hook this unit up without a condenser. Turns out it's not a very common option, or not a very popular one. But if you do not have a condenser and you have this control module, do not jump R to DH, even though the manual says to do so. And my installer, I asked him about it, and he didn't know. So I had him look it up. I had him actually contact Ream, who confirmed that I was right. You do not jump the two when you are not running an external condenser. But anyway, as I was stating earlier, the wiring is a little messy here. I'm going to reconfigure this later on. For example, the main powered pigtail, it deadheads right here. The armored wire, it deadheads right here. There's no transition or anything. So if a good hard kink would cause a short circuit. So what I'm going to do is I'm going to mount it in a handy box, attach it to the side of the furnace, and then I'm going to run my power leads through there in grommets and do it in a nice, clean, right way. The way they did it, not too crazy about it. I'm also going to better dress the thermostat wire. They just taped it to the side, but hey. And just so you know, the reason that the floor is all messy is because there was a very small oil spill many years ago, actually, that I'm just cleaning it up. The stuff that I'm using here is Valspar concrete floor oil stain remover. It's basically a heavy-duty citrus degreaser and what I think to be diatomaceous earth, or some kind of an absorbent material. And what it does is it draws the oil through the porous concrete surface, and then it dries to a fine white powder, which you then sweep up and vacuum. Pretty neat idea. It is working because I've gotten this stain a lot smaller than it was. So this is the third application. It was yeah, probably in the concrete by that far. Good thing I have a concrete floor. Some people have oil furnaces on dirt floors. I've seen it, and well, let's just say it's not a good idea. But back in the day when that was done and it was a common practice, they didn't really care about the environment, but we do now. So, anyway, one of the nice things about this control board, let's shut the unit off right here. One of the nice things about this control board is that it's pretty configurable. The manufacturer of the furnace dictates, so the ECM blower can run in one of 4 different modes or 4 different presets. And the manufacturer of the furnace dictates what preset runs at what speed. So they can set through firmware the speed of the blower in each of the 4 modes. And because it can drive either an ECM or a PSC blower, it's a pretty universal unit. So if I wanted to convert this to a PSC blower, let's say this thing blows up and I don't want to spend the $500 or $600 for a new blower motor, I can still put a PSC in there. It'll plug right in. I believe it goes over here somewhere. That's where the terminals are for PSC. And I can control the speed of the blower using these dip switches. As it stands right now, I have the ability to change the blower speed just by setting these 2 switches here on the cool side. And I'm not going to touch any of the others. But while I'm in here, I'm going to remove that jumper wire completely now that I've confirmed that it is not necessary. It is not needed, it is not used, we do not need it. So we're going to take that jumper wire off. I've cut power to the unit. So we're just going to pull it out. Then we're going to tighten it back up again. There we go. And we're done. So, no dehumidifier. So yeah, if you jump the DH terminal to R and you do not have an external heat pump or condenser, then you are going to be having problems. And strangely enough, it is not documented in the manual. It took the homeowner to figure this out. So, you know, they say homeowners shouldn't mess with their equipment, but sometimes the homeowners aren't as stupid as they sound. I'm just glad it's done. But yeah, I'm going to neaten this up. I'm going to put a proper... I don't know why the installer didn't do that. I didn't call him out on it, and I'm not gonna. That's why I'm not naming him, because I don't want people to give the guy a hard time. You know, he did give me a decent price, and oh yeah, so with the ECM blower, it brought the price from $44,990 to about $5,500. It's a fairly expensive upgrade, apparently. So that's it cost me a little bit more. And the other thing is, I opted not to put a humidifier back in. So when the original furnace was installed, there was a humidifier mounted in this transition up here. And what that does is it basically sprays a mist of water from the water main over here into the unit, and that puts moisture back into the air, which on a forced hot air unit, the moisture is completely lost. In some cases, I decided not to do that to keep things less complicated. A humidifier that malfunctions can destroy a furnace. If the float gets stuck and it floods, it can rust out the heat exchanger. I don't need that. So we're going to keep things simple. If I need a humidifier, I'll put one upstairs. No big deal. So there you have it, folks. Let's take one more look at our burner efficiency rating. So 86.3% when they tested it, 397 degree flue temperature, 4.7 CO2, and 1 part per million carbon monoxide. So that's what a brand new furnace burner stat chart will look like, at least in this case. I look forward to at least 15 winters with this unit. I did pay a considerable amount of money, and I am pleased. I really am. And the other thing is, this thing heats up almost instantly, whereas the old one took a good minute or so, maybe a minute and a half, 2 minutes in some cases, to reach operating temperature. Actually, it was more like a minute, but it took forever to reach operating temperature. This one, it's almost instant. By the time you think to look at a stopwatch, it's ready to go and it's already producing heat, which is pretty nice. And a lot of that has to do with the overall efficiency improvements over the past 65 years. For example, this one has a retention burner. My original burner, which I did save, and here it is. The original burner was a non-retention firing burner. The other thing that really matters is the shape and size of the heat exchanger, which is very, very small compared to the original one. So it heats up faster, transfers heat faster. The other thing is the combustion chamber itself. The original furnace was a brick-lined combustion chamber, which takes a long time to heat up. This one is a refractory combustion chamber, which is made out of a fireproof fibrous material, which heats up almost instantly when the flame is applied. So it holds the heat nicely, and some of that heat is reflected back at the flame to ensure complete and thorough combustion. It's a retention burner, so the flame is shaped more uniformly versus a non-retention burner. So in all, it's just a lot of improvements, a better blower. This is a variable speed blower versus a fixed speed blower, so it's going to be able to produce just the amount of air needed for the circumstances. There are so many improvements in this unit over the old one. Reliability will take a toll because it's completely electronically and computer controlled, whereas the original one was all analog all the time. So I do anticipate more problems as this thing gets older, but the payoff will be in reduced oil consumption. So with that, I thank you all for watching and have a great day.
We're at the Bishop homestead, and we have this handsome boy right here. Today is July 3rd, 2019. He's patiently waiting for his girlfriend's dinner to be ready. And I hope all of YouTube Nation sees this. Over and out.